Hey everyone, we're back to doing pre-calculus and we're on chapter 4 and this is going to be about angles and unit circle stuff, I think. But we'll get right to it. But can you figure out what this background is from? Let's see if you'll figure that out. Okay, so we're going to go here to chapter 4, angles and their measures. And 4.1, which we're doing, is really easy, I think. Hopefully it will be easy for everybody. And let's see how we do. Okay, so first of all, where's my stylus? There's my stylus. We're talking about angles. And the measures of these are in degrees, we can have them in, or we can have them in radians. There's actually a third unit, gradians, which is a funny thing. I had heard it was used in Europe before World War II, and I think it was stopped. I don't know if that's true or not. We're not going to use gradients. So degrees, we can do two ways. We can do in decimal form, or we can do in, oops, spelled it wrong, degrees, minutes, and second, oops, D-S, and seconds. So we'll do that. It's much like how longitude and latitude are done. And for radians, well, they're just going to be in radians. There's only one type of radians, and that's radians. Okay, so first, let's talk about, you already know degrees in decimal form, right? 12.6 degrees, we're all aware of that. And in a circle, all the way around is 360 degrees. We know that. But when we want to do degrees, minutes, seconds, like if I have 30 degrees and I want to convert that, well, let's not do 30. Let's do 32.6 degrees. I can write that as 32 degrees and then something minutes and something seconds. One little slash means minutes, two little slashes means seconds. It's kind of like feet and inches, same thing. And the way we do it is we take the decimal portion here and we're going to convert it. And so I make this, when I'm going from degrees to minutes, I take that number 6/10, and I am going to set it equal to, if I'm doing minutes, there's 60 minutes in an hour, so I'll divide it by 60. And so let's see, if I cross multiply, 360 equals 10x, 360 over 10 equals 36 equals x. So this is 32 degrees, 36 minutes, and notice there's no remainder. That means there's no seconds. The seconds are for the remainder. And this was a convenient one where nothing was left over when I did this division here. So there's nothing needed for the seconds. But let's do one where we have to do seconds, okay? And you can usually tell when you're going to have seconds because you got some weird number. So I'll stick with 32. 32.74 degrees, okay? This one's going to be kind of weird. So this is going to be 32 degrees, some number of minutes, and I bet some number of seconds. So first thing, I take the 74, is this right? And I am going to divide it. Since I'm doing 2 digits, I'm going to do, to get to minutes, I'm going to do 74 over 100. Doing over 100 because I have 2 decimal points, so I have 2 zeros. And I'm going to set that equal to x over 60. And again, I'm going to cross multiply. And where's Mr. Calculator? Oh, Mr. Drawer. And so this will be, you've probably already calculated it, but I'm slow. 60 times 74. Oh, I did that. Oh, I did it. Did I do it right? I did it right. So that's 4440 equals 100x. And when I divide by 100, boop, I get 44.4. So the 44 gets used, let me change to red. This gets used as my minutes. And then I'm going to take the 0.4 that's left over, and I'm going to use that to go to seconds. And the same thing, I'm going to do 4 over 10 equals x over 60. There's only 1 0 because I only have one digit here. If there was another decimal point that I wanted to include, then maybe I would do 2. Do I want to include a decimal point? No, because it comes out exactly 44.4. Cross multiply. 4 times 60 equals 10x. So this is 240 equals 10x. Divide by 10, 24 equals x. So it's 32 degrees, 44 minutes, 24 seconds. That's equivalent to 32.74 degrees. Okay? You just got to do a couple to see the pattern to get used to it. Math is all about patterns. Okay, let's see. What's another one? 28.71 degrees. Let's do that one. Okay, so that's going to be 28 degrees. I take 71, 2 zeros over 100 because it's 2 decimals. I always compare to 60 because there's 60 minutes in an hour. So if I get more than 60 minutes, it would become a degree, just like on the clock, 60 minutes would become an hour. Here, if I'm over 60, it's going to get bumped up to the next degree. So let's see, 71 times 60 equals 100x. 71 times 60 is 4260 equals 100x. Divide by 100. 42.6 equals x. So this is going to be 42 minutes. Now I got to take this and go 6 over 10 equals x over 60. Cross multiply. Oops. 6 times 60 equals 10x. 360 equals 10x. 36 equals x. 36 seconds. So that's how you convert from degrees to degrees, minutes, and seconds, okay? And so you're going to have some problems about converting to these, and I need you to be good at that. I don't consider these a very difficult problem to do. You just need to follow the steps, and you need to practice, and that means do the homework, okay? So convert to degrees, minutes, and seconds. That's important. Now, also in this chapter is converting from degrees to radians. This we'll probably use a lot. And again, on the circle, we're at 0 degrees and then 90 degrees and then 180 degrees, 270 degrees, and 360 is all the way around. This is going around the circle here in degrees. This is the standard direction to go around a circle. So this direction is always positive on a circle. But we can also represent this in radians. And on a circle, 360 degrees is equal to 2 pi radians. Okay? So this is 0, 90 degrees. Let's see, how many radians is 90? Let's see if I can figure this out. So I use a ratio. If I want to convert 90 degrees to radians, I just use a ratio. 360 over 2 pi, these are the same thing, equals 90 degrees over x radians. Now you can remember a conversion equation and do it any way you want. I just do this so I never have to think about it. I'm just using simple ratios. Okay, so to solve for this, I'll cross multiply. 360x equals 2 pi times 90. If it asks for the angle in terms of pi, then that means leave the pi there like it's a variable. If it doesn't ask for it in terms of pi, you can use pi on your calculator and convert this to a number, 1/4, blah, 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 whatever. It goes on forever, but you can just do it that way. Probably it's going to say in terms of pi, because this is a good habit to be in, that you're able to do this and keep pi floating along. So x is going to equal to 2 times 90 times pi over 360. And 2 times 90 is 180 over 360. 180 over 360 is 1/2. So it's pi over 2. 90 degrees is pi over 2 radians. Here's another 90 degrees. Pi over 2 plus pi over 2 is pi radians. Let me do this in a different color. There we go. So this is pi over 2 radians here at 90 degrees. Here, 180 is pi over 2 plus pi over 2 is 2 pi over 2, which is pi radians. 1 pi over 2, 2 pi over 2, down here is 3 pi over 2. And all the way back around is 2 pi. So these are the axes on the unit circle in terms of degrees or radians. Here's how I'm going to convert every one. If I have to convert, I don't know, 2.8 radians into degrees, then I'm going to do 360 over 2 pi equals x degrees over 2.8 radians. Now, I'm not going to change this equation around. I'm going to leave it the same way so that when I solve every problem, the equation is set up the same. It's just a question of where is this variable x going to sit. If I'm solving for degrees, then x is in the degree slot. If I'm converting from degrees to radians, then radians is the unknown, and the x is going to be down here with radians. So again, cross multiply. 2.8 times 360 equals 2 pi x. So in terms of pi, so how are we going to do that? No, not in terms of pi, because it's degrees. Who said that? So divide. So it's going to be 2.8 times 360 over 2 pi. You're just going to crunch this on in your calculator, and you're going to get the degrees for this. Okay? So that's doing the conversion from degrees to radians or from radians to degrees. My advice is use this thing, use the ratio, and make every problem look the same. Some people like to remember, well, if it's, let's see, 37 degrees and I want to change it to radians, so I multiply it by pi over 180 and I'll get the radians. But if I'm doing 4 radians and I want to turn that into degrees, then I do 180 over pi to get the degrees. And now I got to remember 2 equations right here to figure out how I'm going to do this conversion. And I got to make sure I get it right, because if I get it upside down, it's wrong. And now you got to remember 2 equations, and it's not worth it. Remember one equation, use these simple ratios, 360 and 2 pi are the same. 90 degrees and x radians are going to be the same. And it's just easier that way. People don't listen to me. I say this every year. Students nod their head as if they hear what I'm saying, and then they do what they want. So that's up to you. You do your choice, okay? You do you. Now, arc length. Arc length is, if we have a circle and we have an angle in this circle from here to here. Let's say we're at, oops, that's not 30, 60 degrees. And I want to know how long is this arc right here. That's the arc length. Arc length is a length along the perimeter of the circle, but it's bounded by a certain angle. Okay? So in this case, it's 60 degrees of the whole thing. Now, you know something about this already, because you know in a circle, the circumference, which is the distance all the way around a circle, it's the perimeter, is equal 2 pi times the radius. And the area of a circle is pi r squared. Now, people struggle with remembering which one do I use. And I want you to think about, circle is a unit of length. It's like feet or inches or meters. And so it's length to the first power, length to the first power. So it's just meters to the first power. So there should be radius to the first power. That's 2 pi r. Area is like square feet or square inches or meters squared. Oh, look, r squared, meter squared. Right. Area is in square meters. Square is length squared. So it's always going to be pi r squared is the one for area. Okay. Circumference is in units of length to the first power. So it's 2 pi r to the first power. Area is units of length squared. So it's pi r squared, length squared. Okay. So now, how do we use that? That's great, Mark. That was exciting and riveting. Yes, I know. But how do we use it to find the arc length of this thing where the radius is, let's say, 3 inches? And I want to know what's the arc length. Well, I know the area all the way around the circle is 2 pi r, right? But I want to know what my arc length is here, x. So I got to figure that out. Oops. So again, I'm going to use a ratio. 2 pi r is all the way around the circle. 360 degrees is all the way around the circle. My arc length x is only a portion of the circle, as is 60 degrees. So I can use this ratio to figure out what fraction of the circle am I really looking at here. Okay, all the way around the circle, the circumference, all the way around the circle, the degrees, only partially around the circle, because I have this angle that only creates a partial arc length. So again, I'm going to use the ratio to figure this out. Okay, so if I solve for this, I'm going to cross multiply 2 pi r times 60 equals 360x. I know you didn't have to cross multiply. I got to just multiply it by 60, but I try to make every problem look the same. So I'm going to do that anyways. So 2 times 60 is 120. 120 pi r over 360 is going to equal my arc length. And r is 3, right? Yep. So 3 times 120 will be 360 pi. This is kind of weird. Over 360 equals x So what's my arc length? My arc length is pi inches. Boy, that did not come out. Didn't really plan that. That's kind of weird. So it's 3.14 inches is what 60 degrees does. Okay, did I do that right? Yeah, I guess I did. Okay, so because it's 6, yeah, that's right. Okay, that was really unexpected. Okay, so let's try another one. What if I'm not at 60 degrees? We'll leave the radius the same, but I'm at 24 degrees. So now I would say 2 pi r over 360 equals x over 24. Hey, wait a minute. Can I write it as 24 over x? Because these are kind of the same thing. No, because the degrees I have are down here on the denominator. So this is the degrees, and this is the arc length all the way around the circle. So I have to have arc length in the numerator and degrees in the denominator. I can't just, whoops, I can't just flip it around like that. Okay, so this has to be arc length in the numerator, degrees in the denominator. So this will be 6 pi times 24. I'm going to cross multiply, equals 360x. So I did this times this, equals that times that. Divide by 360. So what's 24 times 6? 24, oops, I got to turn it on. 24 times 6. 144. 144 over 360. Oops, pi, can't forget that, equals x. So 144 times pi divided by 360. Boop. 1.256 inches. Now I plugged in for pi 3.14. If you use your pi button, you're going to get a little different. I'm wearing my glasses that helps me see the computer screen, and so I can't really see the buttons on here other than the big numbers, so I don't know where pi is on there. So there you go. So I just put in 3.14. But if you hit the pi button, you're going to get a lot longer number. You're probably going to get a little bigger, and these decimals are going to change. I doubt the 2 changes, but I bet the 5 and 6 change. And that's okay. Let's go on to the next one. Well, is there a next one? Because that's really the bulk of it. Okay, so there is another one. So arc length is very commonly used the letter S to represent arc length. I have no idea why. But here's another way to calculate arc length. S equals R theta. You can do it like this. If theta is in radians. So this is another way to do it. And you've done this before. What's the number of radians all the way around a circle? Right, 2 pi. So the arc length all the way around the circle, according to this equation, is R times 2 pi. Is that right? Oh yeah, because that's 2 pi r. That's the circumference all the way around. So this is another way to find the arc length of a circle, arc length of a piece of a circle, if you know the angle. So if I have this angle, 74 degrees, with a radius of 6 feet, and I want to know what the arc length is. Oops, not 74 degrees. Let's make it 3 3 pi over 7 radians is my angle. Okay? And I want to find what this is. So since I already got it in radians here, well, how would I do it with ratios? I would do 2 pi r, instead of over 360, I would do 2 pi radians equals x over whatever I got, 3 pi over 7. So you could do it that way and cross multiply. The 7 down here is kind of inconvenient, but you can convert 3 over 7 to a decimal, right? And then have it be 0.42 pi or whatever it is. So that's one way to do it. But let's use our new friend, Mr. Arc length equation. And so S equals R theta. So S equals 6 times 3 pi over 7. And let's compute, not 36, that's a times. So 3 pi over 7, 3 times pi. Again, I don't know where my pi button is, so I put in 3.14. So this is 6 times 1.35. Got to do some rounding. It's 1.3457, so I rounded. So 6 times 1.35 equals. So this comes out to be 8.1 units, feet, because the radius was in feet. So this is the arc length, the distance from here to here along the curve is 8.1 feet. So in this case, I gave you the angle and the radius and you solve for the arc length. Maybe I tell you the arc length is 4 meters and the radius is 0.5 meter. No, not 0.5 meter. 6 meters. And what's the angle theta? So S equals R theta. As long as I can give the answer in radians, I can do this. So 4 equals 6 theta. So 4 over 6, which is 2/3, 0.66, I guess 67. Radians equals theta. So this would be the arc length by doing S equals R theta. S equals R theta. Theta comes out in radians. If you needed it in degrees, now I would have to go to change to degrees. 2 pi over 360 equals 0.67 radians over x degrees. And then I could solve for degrees. Okay? Does that make sense? That's the gist of this chapter 4.1. There's a lot of homework problems, a lot of different kinds of homework problems. So I encourage you to do the homework and ask for help and come to office hours. Okay? If you have any questions, I'm always in office hours and I'm available to help. So please reach out. Thanks. Bye.